Welcome, ladies and gentlemen, and we're going to continue our topic of right triangle trigonometry. Now, when we talk about right triangle trigonometry, we're obviously talking about right triangles. Let's take a look at a right triangle real quick. So here's a right triangle. Now, whenever you have a right triangle, by definition, what that means is it has a right angle, which means it has a 90-degree angle. The other two angles will be smaller than 90 degrees, and this 90-degree angles will lead to a hypotenuse. And that hypotenuse is always the longest side, and it's opposite the 90-degree angle. Okay, so there's a B-flat right angle triangle. Now, I could call it ABC. And we could talk about this side length as being side BC, or we could talk about this side being side BA. We could talk about this being BC or side CB, and this could certainly be AC or CA. We are always going to refer to this as the hypotenuse because it's opposite the 90. Now these guys over here, there's another way of talking about the side lengths, and that's to look at the angle opposite the side, and we name it the lowercase of the vertex. So if this is vertex A or angle A, this is opposite vertex A, so we call it angle little a, or sorry, side little a. And this will be side little c. So this is another way of talking about the sides of a triangle. Now, when we talk about angles, that would be angle C. We could also use the Greek letter theta to represent an unknown angle measure. We also use phi, which is a Greek letter also that we use for an unknown angle measure. So this angle up here would be angle A, and we could also call it theta or phi to indicate an unknown angle measurement. Okay, now when we're talking about a right triangle, it's important that we understand that the legs of the triangle can have different names depending on the angle that we are referring to. There's my 90, there's my hypotenuse. It never changes. My hypotenuse is opposite the 90. However, if I'm going to call this angle A, then this side over here would be the side opposite angle A. And this side over here would be the side beside angle A, but not the hypotenuse. Now, mathematicians are lazy. There's no way we're going to talk about beside angle A, but not the hypotenuse. So the first thing we're going to do is change that word beside to a special word called adjacent. And we're going to leave off, but not the hypotenuse, because if it was the hypotenuse, we would call it the hypotenuse. So we leave that off, and we use a special fancy word for the word beside. So this is the side opposite angle A. This is the side adjacent, which means beside angle A. Now, what if I was talking about this angle, however? Let's call this angle C. Then this over here would be the side opposite angle C, and this would be the side adjacent angle C. So the term opposite and adjacent depend on which angle I'm talking about. And we never, ever, ever try to talk about opposite and adjacent from the 90 because the opposite side is the hypotenuse. It's not the opposite side, it's the hypotenuse. And the adjacent side that's not the hypotenuse, well, that doesn't make sense because they're both not the hypotenuse. So it falls apart for the 90-degree angle. So we never, ever, ever do this from the 90. We do it from the two other angles which need to be less than 90 in a right triangle. Okay, next thing. And I notice I'm just drawing right triangles in any sort of orientation just to bug you. So, mathematicians are notoriously lazy, So we're not going to use the whole word hypotenuse, and you'll notice I've done it already here, right? I used the short form height for hypotenuse, and if this is angle A, then I'm going to make this OPP for opposite, and I'm going to make this ADJ for adjacent. So mathematicians are notoriously lazy. We're not going to write out the whole word. We're going to use OPP, ADJ, and HYP for a triangle. So that's how we're going to name a triangle, and that's how we're going to talk about side lengths that are opposite and adjacent to the non-right angle in the triangle. I'll stop there and we'll be right back.